All right, Tanessa, you can start the recording. Thank you. All right, everybody, welcome back, and for another fun-filled afternoon with Arduino. Before we get started, I know I had promised you last time that I would do the extension items, the try it on your own, but I didn't have time to do that. The university opened this week, so I've been pretty busy with that. But I will get to that at a future session. I hope you did get to try it, and if you have questions, as always, you can email me or let me know, and we can see whether you got it right or if you had questions with it. This session is actually going to be pretty easy. We actually only have 2 circuits to work on. But before we get started, if there are any questions, you can put them in the chat window and Tanessa will let me know about it. I'll give you guys about a minute or so, or 30 seconds if you have no questions, if you had questions from the previous sessions. Okay, I'm going to take that as no questions. So what we're doing for the remainder of the sessions is actually going to do anywhere from 2, maybe 3, depending on how hard it is, circuits per session. So today we're actually going to work on the RGB Night-light and the buzzer, and we're going to put that together. In between that, I'm just going to show a couple of things that might help you understand what we're building. And as always, remember that you can go to the Sparkfun activity guide, right, which is at sparkfun.com. You can search for the activity guide, the red board activity guide. Actually, it's just called the red board right here. And there's the guide that starts you off over there. I'm going to go to the one that we're actually working on. Right there, which is the full activity guide. And click on the Night-light, which is what we'll be working on over here. So last week, we worked on the photoresistor and the potentiometer. The potentiometer, as you might remember, is basically a resistor that's variable. A resistor reduces voltage, and a potentiometer is a variable resistor. So it resists voltage by twisting that knob that's right there. A photoresistor is very similar, except the photoresistor, which is right there, is a device that resists electricity based on the amount of light that's hitting it. Today we're going to be putting some of that together, and what we're going to do is work on building a nightlight. So the basic concept is that when the light goes off, the nightlight, which will be a LED light, will turn on. But it's not any LED light. This LED light is actually called an RGB, red, green, blue LED. If you might remember in previous sessions, the LEDs that we've been working with have been a specific color, most often red, yellow, blue, green. This one is an LED that has all 3 colors built into it. And so by varying the amount of colors, you can actually use an RGB light to create all different colors of the rainbow. And it's a really cool device because unlike other LEDs, which only have 2 components, you can control each of the items of each of the strengths of the LED bulb inside there by varying the amount of voltage that you send to the red wire here, or the green wire, or the blue wire over here. And so I'm actually going to show you a little demonstration of that using just a battery and the RGB LED light. Now, one thing very important before I actually show it to you is, of course, there's a positive and a negative to an LED. And most LEDs have just one positive and one negative. Now, because we have many colors, we have to have one negative. And depending on where you send the positive, you can turn on and off different lights inside the LED. So the longest LED, if you can see in this picture, the one that's the longest is what's called the ground, or the negative. And then the others are correspondingly for red, or rather, if you look at this from this top down here, the red is the one that's closest to the negative, so this would be red, and then there's the green, and then there's the blue. Another way you can distinguish it is there is a little flat edge right over here, and if you have your RGB LED from your kit, you can actually feel it. One part of it is curved and the other part of it is flat. And so the flat part right over there, I'm sorry if I pointed there, it's right over there, is the part that's closest to the red. So what we're going to do is I'm just going to show you this LED example using my own setup over here. So I'm going to stop sharing my screen, and so you can see the screen, you can see it on the big screen. And here's the RGB LED light, RGB LED right there, over there. And over here is the flat side, and over here is the curved side. So I know that this is red, this is ground, this is green, and this is blue. Now I have it already wired up here because this is the circuit board that we're using, but I'm just going to use the pins over here, right here, to wire up and show you how it works. So I have here a battery. It's just a regular battery kit right here, and I have two wires coming out of it, a red and a black, the black being ground and the red being positive. So what I'm going to do is I'm going to connect the black into the ground right over there. Okay, and remember that the way that the breadboards work is that all of these are connected together. So now I'm going to take the red wire over here and touch there. I'm going to touch the one that's over here. Check it out, turns red. Well, it might not show clean on the screen, but that's red. Switch on the other side, that's blue, and the one next to it is green. Now if I try and touch both red and blue together, I don't know if I can get it, but it shows up red and green right there. Sorry, blue and green. One's a little bit brighter than the other, but it does mix the colors in together. So if we send electricity on one of the LEDs, that turns on. On the next one, it turns on the green LED inside, and on this side, it turns on the red LED. We're going to take advantage of this feature and be able to send different voltages to the actual pins over here to be able to turn the LED into a nightlight. So I'm going to start sharing my screen again. Give me just a minute. Right? So I just basically have done the exact same thing. I was just using a breadboard to do this example over here. Something that I'm going to show you also in this circuit is a different way of wiring up breadboards. So far, you've been seeing that if you look at my screen over here of the camera, I've been using these jumper wires. Well, I'm going to show you a different type of wire in today's class. It's similar to a jumper wire, but it's used for what's called prototyping. And it's basically the same kind of wire, except rather than being this really long wire over here, it's a really short wire. And it's great for prototyping because you might build a circuit that you want to keep for a while, but all these wires that are jumping all over the place out of your breadboard are really hard to manage. And these jumper wires help you, these shorter jumper wires or prototyping wires help in that process. You can buy these on Amazon. Of course, you don't need it for this class because we'll be using jumper wires, but I did want to show you something like that. That makes it much cleaner. You can see how nice it is on the screen here, where I have the yellow, red, and black wires over there. All right, so let's go back over here. So the RGB Night-light is going to basically follow this logic. What we're going to do is measure the photoresistor, and depending on the value of the photoresistor, we're going to turn on and off the LED and set different colors. But how we set the colors is going to be based using our potentiometer. So the photoresistor will tell us whether the outside light, the ambient light around your room, is on or off. And then the type of color that we want to set for the RGB LED is going to be set using the potentiometer. So by basically measuring the amount of resistance in the potentiometer, we'll be able to choose a different value for the RGB LED. And so the logic for this is actually really good because it uses a lot of if-then-else statements to build it. But first, let's build it. Okay, let's take a look at the design first before we build it. So over here, as you can see, is the Arduino board. What we're going to do is get our voltage, 5 volt and ground, and we're going to connect it to this part of the breadboard right over here. The reason we do that is this is basically a way where we can, rather than wiring each of our devices to the actual 5 volt or ground, we can use this as the 5 volt line and the one on the right as the ground line, and we can feed each of our devices from that. So think of this as a source of, going back to the using water as an example, imagine this as feeding the water, and this stream of electricity is going down here, and we can feed each of our devices using the feed that's coming down here. It makes it a lot easier to wire up your devices. And there are a couple of things that are additionally added to this. We've seen other devices in here before. These are resistors. This is, of course, our potentiometer, which we can turn as we need to control the amount of electricity. Over here is our photoresistor, and then another resistor over here. This is actually very similar to the circuit we built last week. So here we are. This part of the wiring is exactly the same. But what we're doing here is we're also adding our potentiometer over here. And so we wired up the ground over here, the black line, the red line for the positive, and then the blue line tells us what the value of this potentiometer is. And over here, we have the RGB LED light. Remember, the flat edge over here is the part, so the one closest to the flat edge is red, then ground, then green, then blue. And each of these has a resistor that just protects the circuit because we don't want to send too much electricity and burn out the LED. And so you can see the ground line comes over here, connects up to the ground, goes all the way down here. The blue line comes through here, goes up through this blue wire over here, goes all the way over here and connects to pin 11. The green line connects up through the resistor, through the green wire over here, and goes all the way over here and comes to pin 10. The red line goes up over here, takes this detour down this way, and connects up to pin 9. So pin 9, 10, and 11 are going to control the red, green, and blue values. And the ground wire over here provides the ground for that LED. And over here, remember that potentiometers and photoresistors are analog devices, so we're going to use the analog pins over here, and we're going to use analog pin A0 and A1. And here's a picture of it connected up, and I did some of the wiring ahead of time just to save us some time, but I'm going to actually connect them up over here on the screen. So let me stop sharing my screen and switch to the video. All right, so as you can see over here, I've just moved things around a little bit just to make the wires closer. Here is the RGB LED right over here, right? And the flat edge is over here. So this is red, then ground, green, and blue. Here's the resistors that protect the LEDs. Here's the ground wire. And over here, if you noticed, I've used one of these really short prototyping wires to help me keep the circuit board simple over here. And over here is my blue, green, and red wires, which are going to connect up to pin 8, 9, and 10. Over here is my potentiometer. The potentiometer is connected up, positive, negative, and then this wire is going to tell me what the value of the potentiometer is, the variable resistor. And then over here is our photoresistor, right there. And then the value of the photoresistor is going to come up through the yellow wire over here. And lastly, I have the two red and black wires over here, which will tell me the which is used to feed the electricity to the devices over here. So my Arduino board is actually off right now, so I can start wiring things up. And let's go ahead and start with these first. I'm just going to look back at the instructions. The blue wire over here goes to pin 11. So sorry for blocking the screen, but I'm just going to connect that up nicely first and then go over it again. Pin 11. Then the green wire goes to pin 10. And then the red wire goes to pin 9. And of course, I am off by 1. This is one of the hardest things about using the Arduino boards is it's hard to see them when they are so close to each other. So I'm off by 1. And you wouldn't, so many times I put it in the wrong pin and wondered why my program doesn't work, only to go back and look at it and then say, oh, yep, wrong pin. So don't worry, you'll have that nice experience as well. Well, not nice, but experience nonetheless. All right, so let's go back and take a look here. Here is pin 9, 10, and 11, right? And over here is the red wire going into pin 9, the green wire going into pin 10, and the blue wire going into pin 11. And remember, these are digital pins, so when they send power, they send 5 volts up through this, and that's why we have those resistors over here to protect those LEDs. All right, the next is the potentiometer over here. The potentiometer goes into pin A1, analog 1. So I see that over here. I'm going to put that into pin A1. And then I've used a yellow wire here. In the example that you see, it's actually both of them are blue wires. And oftentimes you want to not use the same color for everything so that you can easily distinguish what each device is connected to. Very common to use red for positive and black for ground or negative. So it's nice to reserve those two for that and leave those two as is, leave those two reserved for that. So finally, let's go back and double check. We are connecting our photoresistor to pin A0. I'm looking at my picture. A0 is for the photoresistor right over here, and you can't obviously see that, but if I turn that over here, there's pin A0 and then pin A1 right over there. And then here's our positive, which I'm going to plug into the 5 volt. And you definitely want to get that one right because you don't want to send the wrong voltage. And sure enough, I'm in the wrong pin. That's 5 volts. And then this is ground. Okay, so let's check that. Of course, it's black against black here, so you can't really tell. But that's the black wire over here coming into ground. And that's the 5 volt line coming in there. Okay, try and clearing this out a little bit. And so this, as you can tell, there's a huge difference in all these big wires jumping all over the place versus on the breadboard where I have these flat wires. And so those flat wires are basically the same thing as these jumper wires, except they just run flat against it. And they do come in different lengths. If I move this off, I'm going to show you my little kit of jumper wires. Those are my jumper wires right there. And if it's not the right length, you can just take one open, like I have here. Wait, where was one? I have one here. There it is. No, that's not one. Well, all you do is you take one of these guys and you cut them and to what size you want and just bend the wire. So prototyping jumper wires. All right, let's move this guy back into the screen. So what we're doing is basically measuring the amount of light coming in using a photoresistor, and then measuring that using pin A0. And then we're measuring the value of the potentiometer using pin A1. And then running some code in our little Arduino that, depending on this and this, turn on different LED lights on our RGB LED over here. So I'm actually going to demo it, turn this guy on. Okay, and let me get a little screwdriver to turn this. And you can see the color change. I've blocked the light so that to basically make it look like as though it's nighttime. And you can see as I turn the potentiometer, the light turns to different colors. Now I know it's a little bit bled through on the screen that you can't really see it, but it is changing colors. There's purple all the way, and then blue, and then this is like a cyan, green, off green, darker green, red. Okay. Now, if I actually make a bright light, let me try and it's turning on even though there's light over here because I've turned the sensitivity of the photoresistor to be a high value, and we'll look at the code in just a minute. Okay, and so let me share my screen and let's take a look at the code. Okay. For a minute. Okay, so here's the code, and what I did was I basically took, if you go down in the example for RGB LED, right over here, you can just click on copy code, and then you can go to your Arduino, and if you do a new sketch, you can just delete all that and paste the code that you just copied from the browser. So that's basically all I did. I'm not going to save this. All right, so we've created a couple of variables, and remember, variables are just placeholders for values that you might use later on in your code. The reason they're called variable is what you store in them can change over time. You can also set some variables to some default values. For example, the photoresistor and potentiometers are integers, and we don't need to set them to anything because we're going to read their values from the devices themselves. The threshold is basically a sensor value that says if the photoresistor reading is lower than this, then that means that the night time has been activated, night mode has been activated, so we know that we need to turn on the LEDs. And these are the pins that we remember, 9, 10, and 11. That was in the original wiring, pin 9, 10, and 11. Right? And so here's our setup. Remember that the setup is run once every time the Arduino boots or whenever the Arduino is reset. We set our output mode for where we log our errors to be 9600 baud, and we set our pin modes for the 9, 10, and 11 to be output. Then we go into what's called the loop. The loop runs forever. So this is just going to run forever and ever until you reset or turn off the Arduino. Here we are. We read the photoresistor value. Remember that we connected the photoresistor to A0. Here's the photoresistor line right over there, connected to A0. And then here's the potentiometer. We read pin A1. Here's the potentiometer right here, reading pin A1. All right. We're going to do some debugging. So we just print what the values we read are. The value of the photoresistor and the value of the potentiometer. And then we do a very classic logic statement, which is if the value of our photoresistor is less than the threshold, remember we set threshold to be 500 up here. If that's true, then we do some statements in here. If it's not true, which is basically that there is enough light outside, ambient light, then we turn off the LED. And we don't just turn it off, we actually call a function called turn off. And what does turn off do? Turn off just sets all the values of the RGB pins, red, green, and blue pins, to be 0. All right, so let's go back over here. And so here is our code right here. So we know that our photoresistor, if it's less than threshold, meaning that the light has been turned off, then we check the value of our potentiometer. Remember, the potentiometer is the thing that I just turned with that little knob. If it's between the lower values, set it to red. And then if it's somewhere in between other values, set it to orange or yellow or green, cyan, blue, or magenta. And each of these are basically if statements. If it's between this and this, if potentiometer is greater than 0 and it's less than or equal to 150, call this function. If potentiometer is greater than 150 but less than or equal to 300, call the orange function. If it's greater than 300 but less than or equal to 450, call the yellow. Notice that this says less than or equal to 450, so that means it includes the value 450. Over here it says greater than 450, which means that it's not inclusive of the value 450. And lastly, if it's greater than 900, then call the magenta function. And then it just has a little delay so that we can read the values on the debug. And what do the individual functions do? Well, red turns the red value up 100. It basically sends out a value of 100, which is basically controlling the amount of voltage over there. And the green value to 0 and the blue value to 0. So that means turn on the red. Orange turns on red and a little bit of green and none on the blue. Yellow turns on red and green. Green turns on only green. Cyan is a little bit of green, a little bit of blue. Blue turns on only the blue and leaves the red and green off. Magenta is a little bit of red and a little bit of blue, or red and blue, and no green. And then lastly, of course, there's turning it off. So let's go back over here and let me stop sharing my screen. Actually, I'm going to leave my screen on. You should still be able to see my my video because it's important for me to show you the code. I'm going to turn it on, and I have ambient light in my room right here. So why is the LED turning on? Oh, let's take a look at the serial monitor. Take a look at what the photoresistor value is. See, it's around 800 or so. Okay, but the code for this says that the threshold is 500, right? So if I don't think I saved this. Let me go back over here and push this code over here. Actually, forgot to save it. There we go. Now, the threshold is 500. And so the value I'm reading is 800, and my LED is not turning on. Now I'm going to put my finger over the photoresistor. There we go. The moment I put my finger over the photoresistor, the value dropped below the 500 of the photoresistor. The reason it was lighting up before was I was running some test code and I had actually moved up my threshold to 800, and that's why it was still lighting up. So I'm going to remove my finger, watch the photoresistor value. See how it jumped up to 800? So that means that there is light, and that means that there is no light. Of course, I've covered my finger completely, so that's all it can get down to. There is probably some light leaking in from the side of my finger or something. So let's go ahead and block the light again. and I'm just going to turn the knob. Notice the potentiometer value now. I'm turning the right-hand value is increasing, and the LED light is increasing in color or changing in color following the logic as well. So you can see how a combination of two different devices, the potentiometer and the photoresistor, are being used to control a third device, like an LED. And you can extrapolate from here. You could make it where it could be that it doesn't turn on an LED. Later on, we'll learn how motors work. You could make it turn on a motor. The next example is going to be a buzzer, and we'll learn how music is played. So you could have all kinds of logic that happens because of this. Right? I'm going to get set up for the next demo, but you can ask any questions in the chat window, and I will answer them. Okay, let me disconnect this and bring in this. And I'm going to do this. I've built the circuit, but I had a great suggestion from a listener from the previous session, which is that it is kind of hard sometimes to see me wire this stuff together. So I have wired this, but I'm actually going to show you how to build this using Tinkercad. So we're going to do the same demo, but this time I'm going to do the demo using Tinkercad and build the circuit on Tinkercad. So you can see that you could do it in either one. And Tinkercad, of course, is the virtual Arduino simulator. All right. So what we have here, and you can see it on the video screen, is what's called a buzzer. A buzzer is basically a small device that can be used to generate sound. It does this by vibrating a little disc. If you actually look inside there, there's a little metal disc with a magnetic coil that's being used to move the disc up and down. The magnetic coil basically, the coil is going around a magnetic. It becomes magnetic, and so it can become what's called an electromagnet when electricity is sent through it. And by sending different frequencies of electricity, by pulsing it, you can move the coil up and down and make the metal disc make a buzzing noise. It's very similar to how speakers work. When you have your headphones that you have for your ear pods or anything like that, the fundamentals of it is very similar to how a buzzer works. What it actually does is send a frequency of electricity. And so by pulsing the electricity, you can control the movement of the device up and down, which generates audio noise, audio sounds. The way we do that is actually using something called the tone function. And so let's go take a look at the wiring. So very similar, but very simple design here. We have a potentiometer here, and the potentiometer here is going to actually control the loudness of the buzzer. In this case, I've actually removed the potentiometer because I was using it in the other example. So I'm going to plug it back in over here. And you can see that on there. The buzzer has a positive and a negative. And the positive side of it has the wording on it. The negative doesn't. So the wiring is very simple. Here's the buzzer plugged into the breadboard. We have ground connected up. In this case, we have ground going through the potentiometer to control the amount of electricity, and then positive going from pin 10 all the way over and connecting to the positive side of the buzzer. That's all it is. The potentiometer basically will control the amount of electricity going through it. So I'm going to build the same thing, but as you can see, I built it in the real world, but I'm going to show you how I built it in the virtual world. One second. I'm going to run it just to show you how it works. And I don't know if you guys heard it, but it was playing the happy birthday song. But it might not be coming through the audio on the Zoom, on the WebEx call. So let me go ahead and start from scratch. Okay, so here's the Arduino, here's my buzzer, and here's my potentiometer. And I can control the potentiometer value over here when I'm running the simulation by turning the knob over here. So I'm actually going to get rid of both of those. And so actually, let's get rid of that too. So I actually have created, I have nothing here, and I'm going to go over here and go to Arduino, and I'm just going to take this breadboard and drop it over here. By default, it has some pre-wired, pre-existing wires. I'm going to remove those. Just clicking on them and hitting delete. Okay, let's go take a look at the wiring again. The wiring says connect pin 10 to the buzzer. Oh, I forgot to put the buzzer on there. So how do I find it? B-U-Z-Z-E-R in the search. There it is, piezoelectric buzzer. Now, I know that doesn't say buzzer, but that's the same concept. The type of speaker it is called a piezoelectric buzzer or speaker. Okay, I'm just going to put that over here for now. And then we need a potentiometer. Now, remember that the potentiometer here is just used to control the amount of voltage going in here. So just to make the example simpler, I'm just going to start off with just wiring this without it. And so it's going to be a really easy wiring because all I need to do is connect the ground and the positive, and the ground goes to ground and the positive goes to pin 10. So let's go over here. There's positive, and I'm going to connect that to pin 10. I've got to click there, and then here's the negative, and click that to ground. All right, so I have that wired up. Now if I click on code over here, it shows some pre-existing code over here. I'm going to change that to text instead. It's going to give me a warning because it's going to say, hey, you're going to lose all the code you wrote. By default, there's some code over here. What I'm going to do instead is go here, copy my code, switch back to my Tinkercad, select all that, delete that, and paste the code that we had. And I'll go over the code obviously in just a few minutes, but I just want to run it. Now I'm going to click on Start Simulation. Okay, I heard it through my headphones. I don't know if you heard it, but it was playing Happy Birthday on my headphones. Let me go and click back over here. So the wiring is very, very basic. We've just connected up the two. If you want, I would recommend that when you try yours, you can do the potentiometer. Here's the potentiometer. Oh, gotta make sure you select all components. There's the potentiometer. You can drag it and drop it over here, and then you can add the additional wiring. The beauty of this is you can just run your wires however you want, of course, and you can connect them up. And if you don't like the way it's wired up, you can actually kind of go like that. Oh, let me delete that. If you don't like it going across, you can kind of drag it around and do all kinds of nice arrangements so it looks really cool when you build it. Like that. And another nice thing, you can actually change the colors of the wires so they match. Like, for example, red and black. And you can save your code and come back to it later too. All right, so that's very basically the device itself. I'm going to explain how it works. So the fundamental concept is that it plays a few notes. The notes themselves are used using they created a function called play, and it plays a certain frequency. Now remember that frequencies are in the music world control what sort of sound that you hear. You hear about the A, B, C, D, those different values in music. Well, we use the same concept here when we develop our code. The good thing is that we don't have to know what those frequencies are. They figure that stuff out for us in the code. So let's go take a look at the code. All right. So the example is really simple. The speaker pin, like we know, is pin 10. So let's go back over here. Pin 10. That matches that. Perfect. In our setup, we simply configure that pin 10 to be in output mode. And then in our loop, we call a function called play, and we have it playing the specific frequency for a specific amount of time. So play G for 2, so happy birthday coming through like that. Of course, this was somebody else figured all this part out for us, so we don't have to worry about it. The real heart of this is right here in the function called play. So the play function receives a character and an integer. And if we look at an example up here, here's the character C, and here's the number of beats or the length of time that you want to play that note. Okay, so note contains either C, D, or G, or whatever it is that it's called with. Beats contains this integer value. The next part here is where we configure what the frequencies are. And so this is really one of the other things that the people who developed this code already did for us. They created an array, and remember, an array is basically a list of values. And so here they've created an array of characters, and all the characters are right there that correspond to the music notes, and then the frequencies associated with that. So here's an array of characters, and here's an array of frequencies. This frequencies is an array of integers. Notes is an array of characters. So frequencies contains integer values, and notes contain character values, including a space. All right. Next, what we do is remember that we're called with the function with the value of note, which would have a specific character and how long to play it. So if we look at our for loop over here, what we do is we go through the list of notes, and if we find the note in the array, then we know that the value I contains the index, which is which index? Index 0, 1, 2, 3, all the way up to whatever this is. I think it's 13 or 14. We use that index I to look up the frequency. Right, there's the I right there. And so if we are called with the letter say G over there, all right, then I would be 0, 1, 2, 3, 4. So here is I counting from 0 all the way through the number of notes over there, and this will come to the value 4, and then it will look up the frequency for 4. 0, 1, 2, 3, 4. So the frequency for G is 196. Now, why did I start counting at 0? rather than 1. In the Arduino C programming language, indexes start with 0, not with 1. So this is index 0, this is at index 1, this is at index 2. Very common mistake when you're writing code is to use the wrong index, and so you would be either off by 1 or you might go past the end of the array list. Both will cause your program to crash. Well, the second will cause your program to crash. The first will give you incorrect code logic. So once we get the frequency, then we use this function called tone. Well, tone is not something we wrote. Tone is actually something that the people who wrote the Arduino libraries came up with. You can take a look at what it does, but basically it generates a specific frequency based on what value that you're given it. The pin, the frequency, and the duration, and that's exactly what we're going to be using in our code. We know that we're going to send it out through pin 10. The frequency is the frequency we looked up over here, and then the length of the beats, which is just how long to play that frequency. And right here you can see beats length is set to 150. That basically says that that's the length of it, and we can change how fast or slow the music is played by controlling the amount of the beat length. And lastly, we just wait for a little bit between it just to make it sound better. And here's a list of the frequencies over here. Okay, so let's go back and take a look at this in the real world. I'm going to wire this up. Let me stop sharing my screen so you can see this in the big screen. Remember that this goes to ground, and make sure you go into the right ground pin. Of course, they would put the ground pin right next to the 5-volt pin so that reverse your polarities. And then this goes to pin 10. And I used a really short wire, so I'm actually going to move this over a little bit. Let me connect to pin 10, pin 9, pin 10. Good. There we go. Do it this way. You can't see it, but there's pin 10 right there, the yellow wire going in there. All right, I'm going to turn on my Arduino, and I'm going to upload the code. You guys probably can't hear it, but it is playing the sound. And I'm going to hit the reset button. And it's playing it right there. And I can adjust the volume here. And in fact, it really only plays when the potentiometer is all the way over there. Oh, Linnell says she can hear it. Great. So I'm going to change this just a little bit. I'm going to change the frequency, the beat length. Let me share my screen so you guys can see what I'm doing. So it was playing at a certain, I'm not a musician, so forgive me if I'm using the wrong terms, but it's playing it at a certain speed. So I'm going to speed it up or speed it down. So by dropping my beat length down to, let's say 50, I should be speeding it up because I'm not going to wait as long between each of the individual notes. Okay, so I'm going to hit play. 1 second. Play. Okay. Yep, so it played it faster. So basically what we did was this value right here became shorter because we dropped this value over here. Now let's play it. It was, I think it was 150. So now I'm going to move it to 300. All right. And so now it should play it slower because this, yep. Sure enough, it's playing it much, much longer. And so we can control all of this by just small tweaking here and there. Let me go ahead and stop that. All right. Now, if you notice that the program at the end didn't go back and loop. Normally, most of our stuff, loop runs forever. Remember, when it reaches the bottom, it goes back up and starts again. If you run this one, it only plays the song once. That's because there's what's called a while loop that does nothing. This says, while true, do nothing. Do whatever's in between these curly braces. Well, there's nothing in the curly braces, but it'll keep running this forever. So this is called what's known as an infinite loop. It basically keeps running forever and doesn't, if you had additional code over here, like you did some other stuff, like you wanted to play a different value, whatever, it would never reach here. And so it's basically a way of just getting things stuck in there. Most often infinite loops are bad for code because you don't want to be stuck in that mode. But sometimes due to logic errors or something else, you end up with that. And yeah, you want to try and avoid infinite loops. In this case, they're doing it because they don't want it to keep playing this every time forever. So that's the buzzer. So just a reminder, I will have this code uploaded to the GitHub page, but you can also always find it also in the Sparkfun activity guide. The updated instructions will be uploaded as well, and Tanessa will be uploading the video to our YouTube FAU Libraries YouTube page soon once we've got the recording back from WebEx. And you can always email me if you have questions. So if you haven't done so, please do build these two circuits, try it out, experiment with changing things around a bit, move it to the wrong pin and verify that it doesn't work, those kinds of things. Try using the debug statements. Those are really useful because as you develop other pieces of code, the debug statements are what will allow you to know when you're doing something wrong or right. It's the core of most coding to make sure you have good debug statements. And then next week, what we'll do is we'll come back and we'll be working on a few different, these two, Circuit 6 and Circuit 7, to build those out. If you haven't done so, definitely also try out the Tinkercad version of this. Try and build out the circuit in Tinkercad. Remember that you can go over to the code and you can paste the code and you can run start simulation and give that a go as well. It's a great way to experiment if you don't have the unit itself, or you just want to kind of play with building it and experimenting with different things here. I don't even know what this is. A potato battery. Okay, all right. I guess they have all kinds of stuff in there. All right, so that's pretty much it. Are there any questions? You can put them in the chat window and Tanessa will let me know. I'll give you guys a few minutes. You're welcome. And yeah, have fun. So enjoy it. And if you have questions, email me and we'll do some more fun stuff next week. Thank you everybody for attending. I'll talk to you guys later. Thanks, Tanessa.